seems like partially for methodological reasons, you have to use these methods of looking at rates, you have to look at scalar variables, right?
Yeah.
So you have length, width, weight,
So they're all
ratios, things like that. And I'm thinking about things like the evolution of fashion or music or literature, where, I mean, scalar variables, like you showed, there's going to be these S-curves where the size of a house is going to, or even the size of a phone, because it's going to reach a point of stabilizing selection, you're going to get to some optimum, right? At least more, and whereas if you think about, say, clothing fashions, like wearing stockings and wigs, or Star Trek uniforms, or whatever it might be, you know, there's not that same.
So the adoption, if you look at the adoption curve for these things, it will tend to be S-shaped.
But do you think that there could be dynamics of cultural evolution that are going to perhaps be even more rapidly changing, precisely because there's some arbitrariness to them, there's many more degrees of freedom for them to vary along? I mean, also I'm thinking of grammars and things like that, right? Vocabulary grammars. I mean, you could have a scalar measure of vocabulary size, but the individual words are going to be blinking in and out of existence and changing all over the place, and the rates of evolutionary change might be quite different if you're using a non-scalar measure.
Well, I mean, so basically, this is the question could be worded as to which extent is this representative of cultural evolution in general? And I mean that's a very good question. Well, first, I would argue that. I don't know, I don't see very good reason to think that these rates are any more or less representative of cultural evolution than the rates of biological evolution that I have are representative of biological evolution in general. But that said, I mean, what you're saying is I think, very right. And the reason why I've calculated these I've computed rates in this way was just that I had all these data sets that I could use for the biological record. So it was calculated rates for practical reasons.
I mean, it's still, sorry, to just follow up a little bit. I mean, even for biological traits, I mean, if you think about the complexity of a peacock scale or of a brain or something like that, you can capture those things with linear variables of different kinds, but they're going to summarize.
Yes.
I mean, so this is even, I mean, it's probably a drawback for biological measures too, because they're all looking at antler length or
exactly, length of molar and things like that. But I mean, this is an empirical question, and this is something I would really love to conduct. So, to which extent are rates of change in technologies different than rates of change in other domains of culture? But one problem that I have right now is that I don't see how I would be able to compute rates of change in these domains or in things like institutional norm in such a way that makes it comparable to these rates of change. Yes.
So, fascinating material, Charles. Thank you. At the end of the talk there, you started to get into questions of tempo rather than pace. And this isn't something I know very much about, but it strikes me that there may be fundamental differences in biological evolution and cultural evolution that affect tempo.
What do you mean?
Because, pace is just rapidity over time, right? But the tempo is the timing within a given pace, right? So for your S-shaped curves are basically assessing tempo, right? That is, the pace is the average across the total time span. The tempo is rapid change at the beginning followed by some plateau.
Okay.
And as I understand it, in biological evolution, extremely rapid change inevitably leads to plateau because very strong selection reduces variation. Right? So you have some pool of existing variation that's there, selection operates, so take antibiotic resistance, for example, right? A very small fraction of the extant bacteria exposed to the antibiotic are resistant a little bit to it. Everybody else gets wiped out. They make it, okay, and then that gets refined. So what you have is an extreme bottleneck in genetic variation when there's rapid selection. It's not clear that, for example, technological evolution follows the same pattern, so that you have things like the steam engine never goes away, okay, and it gets brought back again and again in different forms. So now we have solar applications of steam engines. variation didn't disappear. Okay, so that
Well, I mean, there could be variation between trains or engine or whatever. It doesn't mean that the variation between these objects in the population has disappeared. There's a difference between everybody does the same thing and there's variation between.
My point is that the variant hasn't been lost in the sense that the information is still there in the pool of collective knowledge. So when automobiles were first evolving, okay, there were a whole bunch of different engine technologies that were, competing for that space, okay, and basically one or two won out. So the standard internal combustion and the diesel were what won out, and the steam engine lost. Okay, but the fundamental design of the steam engine didn't disappear in the sense that that the information available for subsequent innovation remained there, so that you can then get a solar steam engine being used as a power source now. And that's fundamentally different than the way that rapid, at least very rapid, biological evolution operates, where the only way that information is going to reoccur in the pool is if there's a novel mutation that reintroduces in, because by virtue of that bottleneck, it's been lost.
But I don't know, maybe I'm wrong, but intuitively I would think that there's always a lot of variation in morphologies and body morphologies, for example. It's not the case that natural selection will destroy all the variation in people's height or the size of their foot. And this is really what I'm measuring here. And here I'm not calculating rates between different kind of engine. I'm calculating rates of change in the morphology of the trait. So as so the thickness of the ceramic pot in the population. And that it is not true that cultural selection will destroy completely that variation. I don't see how it is different than the variation in the size of another morphological feature in an animal population. But maybe I'm not.
Maybe we should continue it later. I don't want to monopolize.
Yeah.
Perhaps on a slightly related point, that S-shaped curve you showed for the power of airplane engines must have been restricted to internal combustion engines, because in the beginning around 1940, jet engines came onto the scene, and I imagine that their power would be even greater for their weight. Not to mention rockets in rocket plane, LX-1. So by restricting it, your analysis to only one version of the technology, you get this S-shaped curve. But if you think only about the function being served by the technology, it may continue to be very rapid development, not have quite that S-shaped function.
Right.
And the way to tie that back to biology, in locomotion in animals would be served by the same legs for a very long time. The equivalent here with technology is that technology seems to sprout all kinds of new things to use for locomotion or propelling an airplane that were completely unthought of before. Revolutions that are much, less frequent. So maybe plotting the rate at which revolutions occur might give you a different kind of sense of
But that will be a
evolution in two areas.
different study, and I don't think I would be able to. I could compare these rates of technological breakthrough or what have you against these rates of change. So here so if rates of change are too big or too dramatic, it's going to obscure the phylogenetic relationship between the population. So when there's a very big when there's a technological revolution or what have you, it's going to make it very hard for us archaeologically to assess the historical connection between these two populations. So it will make so this process will make it so that very rapid shift in technologies are just going to be visible archaeologically. I'm not sure if that.
Well, like you showed a picture of hammers.
Yeah.
But
That was another good. That was just for illustrative purpose. I didn't calculate the rates between these hammers.
But it would make a difference whether the thing you measured about the hammer was the length of the handle or the amount of power delivered with each bang. And once you include, huge industrial hammers,
Yeah.
you know, it'd be a very different thing than if you're just talking about the 135.
Yeah, I agree. It just becomes hard at some point. So
Yeah.
you know, I've got this like stone hammer here. How do I calculate? How do I go on and calculate rates of change between that and the industrial hammer?
Right.
Yeah.
I just want to pick up on these. There's also this link between micro and macro evolution, where these S shapes really refer to these sort of microevolutionary processes, and then you're measuring sort of change in size over long periods of time. And I think, picking up on what Dan said, maybe another way of asking his question was, there's different sources of variation in cultural and biological evolution, and the sort of the mutation process constrains evolution, right? And maybe this is what Dan was getting at. With rapid evolution, you do sort of eliminate variation faster, and it's not clear that cultural evolution should be constrained in the same way, where you might be able to keep pumping in new variation sort of independent of selection, whereas that wouldn't be true with biology.
Right,
So, I mean, there might be some difference there.
Right. So,
I-
so how would that bias my analysis?
I don't know, but if you were to sort of model sort of these macroevolutionary processes where you vary the mutation rates, where you're pumping in variation, does that affect the rate of change over macroevolutionary timescales?
Well, I mean, I agree with Charles that for morphological traits, mutation is sort of irrelevant.
It is.
Yeah, I mean, human height is the best studied one, and there are probably thousands of loci involved in affecting height for humans. And lots of genes with small additive effects, a big reservoir of variation to work on. For other kinds of traits, I mean, for lactose absorption and things like that, then it's completely driven by the availability of meat.
And I think one way to account for that is, so I've measured rates using the Darwin, which is we realize it's a very counterintuitive way of measuring rates, but nowadays people are starting to use another metric called a Haldane. And it measures change in terms of standard deviation per generation. So I think it will capture what you're trying to say here. So it's a much more meaningful and intuitive way of measuring selection. It really captures what evolution is. And the reason why I didn't use the Haldane is that to calculate the Haldane, you need the standard deviation in your sample, which is something that archaeologists don't frequently publish. You very often only publish the mean of their samples. And then it's just not clear to me what the generation time would be for cultural evolution. So that's the reason why I didn't use the Haldane, but I think that might solve the question of the variation changing through time.
Yeah, I think, just to follow up very briefly, additionally, information technology is going to make a big difference, right? So if the only source of variation that you have are the physical models of the artifacts being produced today, right, then variants are easily lost. But if you have a historical record that preserves past attempts, so you know that people tried the steam engine at one point for something, and it turned out not to work well for that, but you know how the steam engine worked, then you never lose the information in the way that you lose it for, traits that are controlled by a small number of loci.
You mean because that information is still accessible?
That's right.
Right, yeah. I mean, I don't know if I get the feeling that this is only true for very part of human history.
Yeah.
Yeah, Jeff.
So your regression model posits that rates converge at about 1 month, right? And presumably less than 1 month, biological rates appear faster than cultural rates, right? Because the lines converge there, and then they're going to cross, and the intercept is going to be. So, what does that mean?
They went beyond where they converge.
I mean, does that mean?
I don't know. I wouldn't like overinterpret these things. I mean, these are just two models just to help me to understand what's going on in distribution. But I don't know. I have to think about that. But that might be overinterpreting. I don't know.
So do you think that maybe because when you're using the Darwin, you're not controlling for the generation time, so you have some organisms who are reproducing in the scale of months, some in the scale of years. And so I'm wondering whether, wouldn't it be also interesting if you did control for the generation time in the
Yeah.
biological
Yes,
sample.
yes.
And the cultural sample, I know you mentioned it's complicated, the archaeological record, but it seems that the relevant generation time in the cultural should be the lifetime of an individual
Yes.
if you wanna
Yeah,
compare
you could,
the rate of biological
yeah,
versus
yeah, so,
cultural.
and actually by plotting that, I didn't do it, but it's something I wanna do next. But I get the feeling that most of, the biological rates are gonna be plotted in a very, very narrow space of the plot. So it's not gonna be that, kilometer which is gonna be really, telling us a lot. But, you know, at the end of the day, I'm interested in how human populations and animal populations can keep pace with a common driver like climatic change. And in that regard, I think that absolute time is the relative metric, not necessarily generation time.
So do you have in your data set something about population sizes? Because
You mean in the biology?
either of them, because like the modern technologies may be driven by the fact that you have multiple, not just that it's a market economy, but it's a world scale
Yeah.
market economy, like Koreans and Americans, you know, produce phones with the same metric in mind, and
Yes, yeah. So basically there are more people working at
Yeah.
yes.
do you have, does the archaeological stuff like have some
No.
estimates, or they're
I
just
mean,
not?
there's a lot of estimate of population size in archaeology, but if you ask me, it's all yes. So I mean, we just don't know, but that's certainly another factor that could add again. And also, you know, because we live in larger, better connected population, we could also suffer less frequently of, you know, loss of variance. Yeah.
One more question or perhaps comment, that at the very beginning of your talk, you focused our attention on the last 50,000 years of human evolution. I wonder why you relegated our pre-modern human ancestors to the acultural. What's going on there?
Right, yeah, I mean, I didn't mean to offend
You offended me.
the Africanist fan in the crowd. I mean, I just don't know what, I mean, so I focused at the end of the talk on these modern technologies, but I could also look at, you know, so there's this, if you go farther back enough in time, you've got these Acheulean axes, and which remain unchanged for thousands and thousands of years. And this fact has led to some people, namely Rob Boyd and Pete Richardson, to argue that, well, this cannot be accounted for with our microevolutionary theory, so there must be something else going on. And this is essentially the same argument that Gould made when he observed all that stasis in the fossil record. So then he said, well, there's no way our microevolutionary theory can account for all that stasis, so we need to amend our theory. And that method here allows us to, controlling for time interval, are Acheulean axes really changing more slowly than archaeological data. This is something I've tried to do very hard because I thought it would be a sexy result to get, but the thing is with Acheulean axes that it's very hard to get a good date and get average for very specific assemblages. But I've derived at some point like how much change should you expect for cultural evolution when the time interval is 1 million years. And it is, I forgot what it is, but it is way much more than anything you see, than what you see with Acheulean axis. So these guys are probably right in saying that there's something else perhaps that's going on with Acheulean axis. But I mean, the methods that I'm using here, Jeff, could be used to compare is the culture of other hominid species. If you can associate artifactual assemblages to specific species, you could ask the question: are these things changing more or less rapidly than modern human cultures? That would be an interesting question.
So in your graph where you compared the modern and the traditional technologies, I'm wondering what period of time the modern starts, because I'm wondering whether there's any effect on technological development rates post-demographic transition. Like, I think some people have argued that it's created increased technological growth.
That could very well be the case. All these technologies, I think my earliest ones start in the 70s. So I look at how much information you can store in these cards that people word function. And then it gets into the 90, like Rob used, and the very early period. So that, again, that's another question. It's like using that method, we could ask the question, does the demographic transition lead to faster rates of evolution than what we've seen before? But the way I was thinking about that result is that it could be that if you were to travel back in time and observe the first 50 years of ceramic technology, you know, you might realize that these technologies were changing very rapidly. You know, every people were complaining that as soon as you buy a ceramic pot, bam, it's outdated. They make these less than perfect on purpose. So it could be the case. I don't know how you could test for that, but it could be the case.
Are there any studies of technological innovation and evolution in ethnographic cases? Because then you could test the cell phone versus somebody today, you know, sort of some indigenous sort of development of technology, because you're not constrained by the archaeology then.
Yes. I know some people have the data. I don't have it.
Yeah.
I know it's being done. A lot of people. I know Michelle I think is collecting data like that in Fiji. So it'll be interesting to compare. So,
Yeah, so you also have, going back to Sarah's question, which you dismissed, but kind of, but you also have possible differences in generation times and cultural traits. So you have houses, for example, that maybe like get rebuilt, I don't know, once every 50 years versus, I don't know what the principled categorization technique you would use for doing this, but there seems to be variation in generation time for technologies as well.
I think use life is the.
Yeah, so you guys have that concept.
Well,
That's a concept, yeah.
Well operationalized.
Yeah.
Well, that's actually a very good point. I've got some data, some rates calculated from things like houses, but most of the data comes from ceramic technologies and lithic technologies. I think these have a relatively short lifespan, but that's totally something that I should look for. But remember that, you know, just this is also true for the biological evolution. It's going to depend on the generation time of the species or on the lifetime of these technologies, but because of generational overlap, you will be able nonetheless to observe evolutionary change over smaller time interval than the generation time. Because in the population there's a lot of generational overlap. So you could argue that the same goes for culture. Yeah.
It seems like just using the human lifespan as a generation also doesn't work well. So the biological adaptation, like the size of your foot, right, that's not going to, for the most part, change over that individual's lifespan, right? Whereas if you're making pots, you could start off making one kind of pot, and over your lifespan, you can have it.
Yeah, well, yeah, and that was my point. That generation, like, and culture evolution frees us from that generation time. So in that case, it's just not clear how meaningful how they calculated like 20, 25 years generation time.
Any more questions?